Atmospheric rivers are narrow corridors of water vapor transport across the mid-latitudes and form a part of the larger warm conveyor belt of extratropical cyclones. Atmospheric rivers are generally characterized by integrated water vapor concentrations greater than 2 centimeters thick, strong low-level winds generally greater than 12.5 meters per second, and a long narrow shape between 300 and 500 kilometers wide. Atmospheric rivers can travel in excess of 48 kilometers per hour, span entire ocean basins, transporting more water than 7 to 15 Mississippi rivers combined. Atmospheric rivers are responsible for producing significant precipitation in the form of both rain and snow in the western United States. When atmospheric rivers move inland and rise over mountain ranges, the water vapor rises and cools, resulting in heavy precipitation, also known as orographic enhancement. Although many atmospheric rivers are weak systems that merely provide beneficial rain or snow, the majority of the more extreme atmospheric rivers can produce extreme rainfall, leading to localized flooding. California is regularly bombarded by atmospheric rivers as they contribute to roughly 20 to 50% of the state's precipitation and streamflow totals. The most prevailing precipitation mechanism in the bulk of California's extreme precipitation events is orographic enhancement. February of 2019 was an exceptionally wet month for Northern California. According to the Center for Western Weather and Water Extremes, 6 atmospheric rivers made landfall over the west coast of the United States in February alone. When comparing February of 2019 to February of 2018, both years contained 6 landfalling atmospheric rivers, but the differences in distribution resulted in immensely different precipitation totals. Located in Northern California, the Russian River watershed is no stranger to the forces of atmospheric rivers. The Russian River watershed drains 3 major rivers, dozens of creeks, and roughly 3,846 square kilometers in Sonoma and Mendocino counties. The communities within the watershed are all too familiar to frequent flooding, as the river reaches flood stage roughly 5 times every decade, and Sonoma County alone experiences about 30% of California's total repetitive flood losses, the highest in the state. Displayed here is a Russian River gauge height time series and a discharge time series for the month of February in Kernville, California. In both time series, we can see a small spike followed by 2 much larger spikes. It's important to note that the flood stage for the Russian River is 32 feet, which was exceeded twice, February 15th and February 26th. This streamflow data correlates with the atmospheric rivers making landfall throughout the month. The atmospheric rivers in particular that greatly impacted the region were on February 26th and February 27th. Several locations across Northern California experienced over 127 millimeters of rain, with 542 millimeters falling in Vernado. Santa Rosa received its highest 24-hour precipitation accumulation on record, 141 millimeters. Since the early 2000s, California has acknowledged that greater coordination of flood control management must be achieved to meet the expanding water resource demands. On a long-term average, atmospheric rivers contribute nearly 20 to 50% of California's precipitation totals, and when storms either don't arrive or underperform, the water resources throughout the state suffer. Improved monitoring and observation-based processes will help predict and understand atmospheric rivers, as well as provide critical information for flood control managers, reservoir operators, and water supply authorities to help mitigate the risk of major flood events.